For years, NASA has monitored a strange anomaly in Earth's magnetic field, a giant region of lower magnetic intensity in the skies stretching out between South America and Southwest Africa. This vast developing phenomenon, called the South Atlantic Anomaly, has intrigued and concerned scientists for decades, and perhaps none more so than NASA researchers. The space agency's satellites and spacecraft are particularly vulnerable to the weakened magnetic field within the anomaly, and the resulting exposure to charged particles from the Sun. Likened by NASA to a dent in Earth's magnetic field, or a kind of pothole in space, the South Atlantic Anomaly, SAA, has expanded by around half the size of continental Europe since 2014, while its magnetic intensity weakens, according to the latest data. It generally doesn't affect life on Earth, but the same can't be said for orbital spacecraft, including the International Space Station, which pass directly through the anomaly as they loop around the planet in low Earth orbit. During these encounters, the reduced magnetic field strength inside the anomaly means technological systems on board satellites can short-circuit and malfunction if they become struck by high-energy protons emanating from the Sun. These random hits may usually only produce low-level glitches, but they do carry the risk of causing significant data loss or even permanent damage to key components, threats obliging satellite operators to routinely shut down spacecraft systems before spacecraft enter the anomaly zone. Mitigating those hazards in space is one reason NASA is tracking the SAA. Another is that the mystery of the anomaly represents a great opportunity to investigate a complex and difficult-to-understand phenomenon, and NASA's broad resources and research groups are uniquely well appointed to study the occurrence. The magnetic field is actually a superposition of fields from many current sources, geophysicist Terry Sabaka from NASA's Goddard Space Flight Center explained in 2020. The primary source is considered to be a swirling ocean of molten iron inside Earth's outer core, thousands of kilometers below the ground. The movement of that mass generates electrical currents that create Earth's magnetic field, but not necessarily uniformly, it seems. A huge reservoir of dense rock called the African Large Low Shear Velocity Province, located about 2,900 kilometers, 1,800 miles, below the African continent, is thought to disturb the field's generation, resulting in the dramatic weakening effect, which is aided by the tilt of the planet's magnetic axis. The observed SAA can be also interpreted as a consequence of weakening dominance of the dipole field in the region. More specifically, a localized field with reversed polarity grows strongly in the SAA region, thus making the field intensity very weak, weaker than that of the surrounding regions. While there's much scientists still don't fully understand about the anomaly and its implications, new insights are continually shedding light on this strange phenomenon. For example, one study led by NASA heliophysicists in 2016 revealed the SAA slowly drifts around, which was confirmed by subsequent tracking from CubeSats in research published in 2021. It's not just moving, however. Even more remarkably, the phenomenon seems to be in the process of splitting, with researchers in 2020 discovering that the SAA appeared to be dividing into two distinct cells, each representing a separate center of minimum magnetic intensity within the greater anomaly. Just what that means for the future of the SAA remains unknown, but there's evidence to suggest that the anomaly is not a new appearance. A study published in July 2020 indicated the phenomenon is not a freak event of recent times, but a recurrent magnetic event that may have affected Earth since as far back as 11 million years ago. If so, that could signal that the South Atlantic Anomaly is not a trigger or precursor to the entire planet's magnetic field flipping, which is something that actually happens, if not for hundreds of thousands of years at a time. A study published in 2024 found the SAA also has an impact on auroras seen on Earth. And just last month, ESA's SWARM mission, a trio of satellites working together to map the geomagnetic field, revealed new complexities. It's changing differently towards Africa than it is near South America. There's something special happening in this region that is causing the field to weaken in a more intense way. Obviously, huge questions remain, but with so much going on with this vast magnetic oddity, it's good to know the world's most powerful space agency is watching closely. Even though the SAA is slow-moving, it is going through some change in morphology, so it's also important that we keep observing it by having continued missions. Because that's what helps scientists make models and predictions.